Hey everyone, today we'll be talking about a particular kind of domain problem. Often, you'll be given a rule and a codomain and need to find the largest set that could act as a potential domain where this rule will not break. Here, for example, my codomain is the set 1, 2, 3, and 4, and my rule is that f of x goes to x plus 1. Now notice that 0, for example, is allowed to be in this domain because under this rule it maps to 1. But something like 47 or 12.6 would both not be valid because they would map to 48 and to 13.6, which are not in this target codomain. In this case, it's fairly straightforward to see that 0, 1, 2, and 3 is going to be the biggest possible domain, since this covers everything and nothing else will possibly work. But I want you to take this example and use it to internalize that concept. That is, that we're looking for essentially the valid set of potential departure points, to use the flight plan analogy. We're looking for everywhere we could take off from and get to one of our allowed destinations. Alright, in college algebra, your allowed destinations will almost always be all the real numbers, so R. Now there are two ways that your function will fail to land in R in a college algebra functions problem. The first way is taking the square root of a negative number, which you see one of here, or one possible way to do it here. And the second way is a division by 0, of which in this example there are two possible culprits because there are two denominators. The typical way to do these problems is to start by assuming that every number is a valid departure point and start taking out the numbers that don't work. So first, let's examine our first way to break things, taking the square root of a negative number. We know that if k is a negative number, or it's less than 0, it breaks. Okay, so that's our first class of things that don't work. Looking at the second possible breakpoint, this division by a number, we know that if k minus 7 equals 0, we will divide by 0, and thus we will break things. So if k is equal to 7, we break things. And finally, our third breakpoint is this denominator right here. So we know that if k minus 6 times k plus 4 equals 0, we break. This is equivalent to saying that if k minus 6 equals 0, we break, or if k plus 4 equals 0, we break. This gives us the breakpoints k equals 6 and k equals negative 4. Okay, so these are our breakpoints. To get a better sense of what this looks like, I'm going to draw it on the number line. So for k is less than 0, I'm going to highlight out all of this. K equals 7 is going to lie somewhere over here. So we know this spot doesn't work either. K equals 6 will be just a little bit to the left. And k equals minus 4 will be back here, which we've already really covered. And that leaves as our valid inputs all the numbers, including 0, from 0 to 6, but not including 6, and then all the numbers strictly between 6 and 7, and then everything past 7. Now this is a fine way of visualizing the domain, but in general we want our mathematical notation to be a little more compact. So the standard way to write this set is to use what's called interval notation. So to write this green set in interval notation, we're first going to want to indicate the section of the number line falling between 0 and 6. And that's written as so, with a square bracket, 0, comma, 6 with a parentheses, where the two numbers indicate the ends of your interval, and the bracket indicates that we are including 0, and the parentheses indicates that we are not including 6. This is very important to get right, because this is one of the most common ways I see students trip up when they're trying to represent sets in interval notation. Next, we use the union symbol, indicated by a large capital U, to combine this interval with our interval between 6 and 7. Because we're not including 6, we use a parentheses. So parentheses 6. We use our other endpoint, 7. And because we're also not including 7, right, that was one of our breakpoints, we use a parentheses to close out the interval. Then we want to combine that with our last interval, which is everything from 7 onward. So union parentheses, because we still don't include 7. 7 as one of our endpoints, and then to indicate that it goes on forever, we just use the infinity symbol in a parentheses, because including infinity doesn't really make sense. So that's the way you're supposed to represent these sets. This interval notation is the same as this set that I've drawn on the number line here. As a side note, it doesn't actually matter what order you combine these three intervals in. You could have written 0, 6, and then union 7, infinity, and then union the middle interval, but it's generally good practice to just put them in order. Alright, so that's the two common things you'll need to handle with domain: square roots and division by 0. And one of the common pitfalls, which is the bracket versus parentheses. The second common pitfall that I see with these problems is overzealous simplification. And what do I mean by that? Well, take a look at these two examples. We have the rules h of z equals z minus 1 over z, all over z minus 1, and the rules j of n equals 1 over the square root of n minus 1 times square root of n minus 1 plus 1 over the square root of n minus 1. Now, if you're an astute viewer, you might say, well, doesn't this just equal, 1 over z, right, if you cancel out these two? Isn't that what you're left with? In that case, the only thing I need to worry about is z being 0, right? Similarly, doesn't this expression simplify to root n minus 1 over root n minus 1 plus 1 over root n minus 1 times root n minus 1? And doesn't that just equal 1 plus 1 over n minus 1, leaving me just one thing to worry about? And the answer is no. You have to respect the original definition of the rule and go through every intermediate step. You can see this if I try and plug in z, or z equals 1 into the original rule of h of z. We get h of 1 is equal to 1 minus 1 over 1 all over 1 minus 1, which equals 0 over 1 all over 0. And that breaks. Meanwhile, 1 over 1 from up here is just equal to 1, right? These two are clearly not equal for this particular case. For almost every single number, this expression right here is equal to 1 over z, right? The simplification works for almost every number. But because it doesn't for some, for these domain problems, you need to look through the original function and identify all your breakpoints. For this one, you've got 2, division by 0, and division by 0. And for j of n, you've got 3, depending on how you count. You've got square root of negative number, possible division by 0, possible square root of negative number, possible square root of a negative number, and possible division by 0. Meanwhile, in your falsely simplified version, you've only got one breakpoint right here, your possible division by 0. This is a very, very tricky thing to get right sometimes. I myself have forgotten about this. So make sure every time you do one of these problems to pay close attention to this, because it really can get you. I've taken the liberty of illustrating the folly of simplification with an example. Let's say you're trying to get home from school, and there are 2 possible paths for you to take. The first one, you just take the bus, as you usually do, and you get to your home safely in about 20 minutes. In the second one, you decide to buy a ticket to Spain, and while you're there, rob a bank, take your ill-gotten gains, join a convent in Brazil, wire all your money to your bank after you realize the error of your ways, fly back to your hometown, time travel 4 years back in the past, and take the bus to get home. Exactly, right? The same way as you would have gotten there as if you just took the bus in the first place. Now, obviously, these paths are not the same, even though at a glance they seem to get you to the same destination with the same results, right? One of them obviously breaks things. You've flown to Brazil and robbed a bank. These intermediate steps in h of z, like right here, and in j of n, like right here, these are where you rob the bank and fly to Brazil. You go wildly outside of your original codomain by taking square roots and dividing by 0, but it appears that you've arrived at a correct destination when really you haven't. So anyway, keep that in mind when you do these problems. Otherwise, that has been Problems of Domain, and that'll be all for today. Thank you guys all for watching.